Okay, guys, let's talk about scalar multiplication. Scalar multiplication of vectors is basically multiplication by a constant. Okay, so let's take just a sample vector. Okay, let's call it v. And let's just say it is 3, 5. Okay, so that would put it in the first quadrant and it would look like this. Okay, so now what I'm going to do is I'm going to take my vector v and I'm going to start multiplying by just numbers. Okay, so let's multiply v by 2. So 2 times v. So what that does is it gives us a new vector of 6, 10. So if I graph that, what happened to our vector, do you think? What was the effect? Well, it looks like what happened. Ask yourself what changed, what stayed the same. Okay, well, it looks like our x and y got multiplied by 2. Okay, so since vectors are magnitude and direction, well, what happened to the magnitude? The magnitude what happened to it? Well, let's find the magnitude of just v. So if I find the magnitude, I get 3 squared plus 5 squared square root. So that's 9 plus 25, which is 34. So I get the square root of 34. And then if I find the magnitude of 2v, I get 6 plus 10 squared, which is 136. Now if I simplify that, I get 2 times radical 34. So it looks like the magnitude doubled or was multiplied by 2. Okay, now what happened to the direction? Do you think theta changed? I don't think so. It has the same slope, right? So theta did not change. So theta remains the same. Okay? Now, ask yourself what you think might happen if I multiplied by a 4. What would happen to my vector? what do you think would happen? Well, let's take the same vector. Okay, remember your vector was 3, 5. We're going to do 4. So did the magnitude change? How did it change? Did the direction angle change? What do you think? So magnitude increases by a factor of 4. Oops. And theta does not change. Okay? All right. Now, so what do you think would happen if I multiplied by a fraction? So less than 1, but still positive. What do you think would happen? So let's say I have a vector. Let's call it t. Let's say it's -10, -6. And let's say I wanted to do 1/2 of that. Okay, well, let's draw it. Okay. All right, so -10, 3, 6, 9, 10. So there's my original vector t. Now I'm going to multiply it by 1/2, see what happens. My line isn't very straight. Rulers help. So that's 1/2 t. So what do you think happened? So the angle didn't change. What happened to the magnitude? Well, let's find the original magnitude. Okay, so here's my original magnitude. Here is the magnitude of the 1/2. And let's see what happened. So this would be 136. Okay, which if I simplify that is 2 square root 34. And if I find, let's see, that would be, hey, look at that. It's half of it. Okay, So that demonstrates that if you multiply by a fraction, it changes or shortens your vector. Okay. This is kind of similar to vertical stretch and vertical compress, like a parabola, right? Remember that? Okay. So I haven't changed the direction yet. So I've multiplied by a number bigger than 1. I've multiplied by a number less than 1. I have not multiplied by a negative. So what happens when the scalar is negative? Okay, so let's take a vector. Let's call it r. Let's do 4 and then 6. Okay, so let's do a negative r. Multiply it by a negative 1. And let's see what happens. Now, some of you might be able to figure out what happens without drawing a picture. And if you have to draw a picture, that's okay too. Okay. So again, we're just multiplying by a negative 1. So there's my original vector r. And then here is my new vector. So what happened? Well, if I multiply by a negative 1, it doesn't change the magnitude, but it did change the direction. Okay, well, so this looks like a change of an opposite, right? Okay, or an add of 180 degrees. Okay, so that's what a scalar does. Okay, so let's summarize this for a bit. Okay, typically we call scalars k. Okay, so if k is greater than 1, it's going to lengthen the vector's magnitude by a factor of k. All right. If k is between 0 and 1, but still positive, it's going to shorten the length of the vector. Okay, by half, 1/3, 3/4, any number less than 1. Okay. And if k is negative, it will change the direction. Okay? All right. So let's try to guess what would happen Okay, so let's say I have a negative 5 times a vector of 2, 3. Okay, so what's going to happen? Theta will change direction by 180 degrees. And then the 5, the vector's magnitude, will lengthen by a factor of 5. Okay, let's do 2/3. Okay, what will happen? Theta will remain the same. And then the vector's magnitude will be 2/3 of its original length. All right, and that is scalar multiplication.